61A Lecture 34 Q&A. Yeah, good question. So if you have a select statement with a group by clause, and the group by has 3 different column names separated by commas, what happens? So we have select something something, group by, column name, column email, column city, or whatever. Bad example. Name, city, and what's an interesting characteristic? Shoes. If you had some big table full of people, and they had names and they had cities where they're from and they had shoe sizes or whatever. If you just group by name, then you'll put all the Johns in the same group. If you group by name, comma, city, then if there are Johns in one city, Berkeley, and Johns in another city, Oakland, they will be in different groups. But there still might be multiple Johns in Oakland. To group by 3 different columns means that you're separating the Oakland Johns with a large shoe size from the Oakland Johns with a small shoe size. So basically what this does is it finds all combinations of a person's name, what city they're from, and their shoe size, and makes a group for each of those combinations. And at that point, there still might be 2 Johns in Oakland with the same shoe size. And so it's not like these groups necessarily have one thing in them. But the more columns you include here, the more groups you're going to get. And those groups are associated with unique combinations of values for each of these 3 columns. Yeah, let's talk about let. So let is a lot like define, where you're defining symbols as opposed to procedures. So this kind of define. Except that when you define, X will remain bound, like no matter what you do next. Whereas let only binds a symbol to a value for a little while. And what do I mean by a little while? Well, until you reach the closing parenthesis of the let special form. So let has always 2 parts. The new symbol bindings that you want to create, and then some expression that you want to evaluate. And the value of the whole let expression is equal to the value of whatever this last expression is. And this part here is just there in order to let you set up some symbols that you will use in this final expression. So I could let X be equal to 1 plus 2. Now I've done some work already, right? I've bound X to the value 3. I do that by writing a pair where the first element is X and the second element is some value, some expression, which gives me some value. And then I can use X. So I could figure out, oh, what's 3 times 4? And it will tell me 12. So this is particularly relevant because there's an extra credit problem in Scheme, which is supposed to translate this. And how would you translate this into an expression that doesn't involve let? Well, you could use a different mechanism for binding symbols to values. You could use a lambda expression. So when I say lambda x times x4, I'm basically saying X is going to be bound to some value, and then I'm going to compute this result. Oh, that's the same thing with let. Let says X is going to be bound to some value, and then I'll compute this result. But where do you set up the value for X? Well, that would be in the call to the lambda function. Here's where you say X is 1 plus 2. And this will give me that same value, 12. So these are equivalent. It's just that let is convenient because you kind of set things up first, and then you compute what you want. Whereas this kind of does it backwards. This says, here's what I'm going to compute, and then I have to put all the values in.
So this is a great example because it's exactly what let does. It's a local variable. Think about it. The scope of it is only within, if you think about the scope of a variable in a function, it's only scoped in the function. It's the same thing with the let. And this very nicely illustrates that. I like that example.
Right. So in either case, x is not bound here. Okay, so two things. What happens when you have a lambda that has more than one line? Like it computes 1 plus x, and then it computes 2 plus x. Well, the answer is that both of these are body expressions. But when you call this on, say, 5, you'll get 7. It really did compute 6 along the way, but it didn't do anything with it. And so it was basically lost at the end. The value of a call to any procedure is the value of its last sub-expression, if there are more than one. So like, what's the point of having these? Well, you could make scheme do something with it, like print it out, and then you'd see that the 6 really was computed, and now we're printing it out, and now you see both. So the answer to what do you do in the case that there are multiple body expressions is that you evaluate each one in order, but you just return the value of the last one. Okay, so a second question was, what is going on here? Let's take a look. This says, create a procedure which takes in x, evaluates a, which is like something that must be defined already. Otherwise, this would crash. And then you let the symbol a equal x, and you evaluate a again. But this a might be different from this a, because this a is bound to whatever x was, the value of x, whereas this a must have been there already. So if I evaluate this directly, if I call this on, let's say, 12, it will give me an error that says unknown identifier a. But if I define a to be something, then I can evaluate this. This will evaluate to 7. This will evaluate to 12. Since there are 2 expressions, we never really see the 7. If we change this just a little bit in order to print this out, we would see the 7. And it's basically showing that, within the body of the same procedure, a could be 7, and then it could be 12 if a, the second time, was inside a let that rebound a. The question is, here's some demos from today's lecture. There's this line that's like, build a connection to some database. And then, we give it a name. You give it any name you want, DB or N or something like that. What would happen if you evaluated this same expression a second time? Would that give you a new database, or the same database, or would it erase the old one? Like, what's the story? And the story is that this name, which describes the name of a file on your file system, is a database that won't ever kind of just get erased. Instead, it's persistent. Even if you quit Python and start Python again, it will retain whatever information was in it before. If you evaluate this expression multiple times, then you just get multiple connections to the same database with the same data in it. And that's okay. Actually, databases are designed to have multiple connections. And what do these connections mean? That means different programs might all be changing the database or querying the database at the same time. But that doesn't mean that the database is going to get refreshed or changed or something like that. It basically just stays there and accumulates information over time. And you can, if one program changes it and then another program queries it, that second program is going to see the changes from the first program. So I think within a particular Python program, there really isn't a good reason to have multiple connections. Usually those multiple connections come from multiple Python programs, or maybe they're not all Python. But you certainly could do it, and I don't think anything would break. I guess the question is, what happens when you define something within a let, for example, or like you have a define that's deeply embedded somewhere? I guess I misspoke about let earlier. You can have multiple expressions, and it just evaluates the last one as the value of the whole let, kind of like a lambda. What would happen if this expression here wasn't just evaluate x, but it was define a to be x, and then we compute x plus 1? Well, the value is the same. The value is just whatever x plus 1 is. But we have a define expression in here, and so we can look up what a is, and it tells us a is nothing, because it all happened kind of within the let. On the other hand, if you define a here, and you wonder what x plus a is, you could refer to a within this expression, because you just defined it. So you defined x to be 1, you defined a to be x, which is 1, and now you're adding 1 and 1 together, and you get 2. So I think the answer to the question of what happens when you have an embedded define is if it's within a lambda or a procedure or a let, then it kind of defines it within that scope. Otherwise, it could actually be defining it more broadly. So if I say something like, if 2 is greater than 1, which is true, then I'm going to define y to be 7. Otherwise, I'll define y to be 8. And then I could say, what's y? And it's 7. So it's not like the define only ever works within the scope you're in. It's lets are just like procedure calls, like define set something in the local frame, and right, as long as you're in that frame, you can access it, and as soon as you leave that local frame, then you can't access it anymore. All right, so we're going to look at this test case together from question 14, and let's just step through it, see what we learn. No, I think all the action starts here. So we define z to be 0, and then what happens when we let a be the result of defining z to be z plus 1? Well, when you define z, well, we can see it right here. When you evaluate a define expression, it does have a value. That value is a symbol. So if I said something like define a to be define z0, what is a now? It's bound to the symbol z. It's as if I had said define a to be the symbol z. I'd get the same result. So here we are using a let expression to assign a to some value, and that value happens to be a symbol, the symbol z. Now, what is z after we do this definition? It's 1. What was a in here? A was bound to the symbol z. So if instead I had written that, then I would have seen z. But really what this is checking is to make sure that you're actually evaluating the define expression. And when you evaluate the define expression, then z should change. Okay, so we got to go back to the beginning, because I kind of did this twice. Now, z is bound to 1, a is not defined. What would happen if we wrote this expression? This expression says bind x to 1 and y to 3, and then do 2 things. Define x to be x plus 1. So now x is bound to 2. And what would happen if I listed out x and y? Well, I'd list out 2 and 3. So I guess like whether we had written this thing or we had just written that thing alone, we'd get the same effect, which would be that z is 1 now instead of 0. Yeah, interesting. So the question is about group by, where you're writing some arbitrary expression, not just a column name, but any old thing. So I put 1, 2, 3, and 5 in a table. If I want to know well, okay, let me do the exact question that you did, which is like, how many of these are bigger than 1 and how many of these are not bigger than 1? Well, I could write an expression that says, is n bigger than 1? And I could also count how many different values fall into a group. Oh, come on. N bigger than 1, count star from the numbers table, group by, and here I'm going to write some arbitrary expression, n greater than 1. What happens? I get two groups. I get a group where I've grouped together all the rows where n is not bigger than 1. 0 is kind of representing false value here in SQL. And then I've grouped together all the rows where n is bigger than 1, where 1 is representing a true value. And then these counts are how many different rows were less than 1 and how many, or sorry, were not bigger than 1 and how many rows were bigger than 1. So it is certainly possible to group by some arbitrary expression, or you could even have a comma-separated list of multiple arbitrary expressions. And, would you do this? I think there's a reason it's built into the language. It really depends on what table you have and what you want. So if it turns out the table you have doesn't have a column for bigger than 1 or less than or not bigger than 1, but that's like a really important part of what computation you're doing, then it makes sense to have like a group by there. I think it's a little more common just to have another column in your table, which would have these values in it about whether something is bigger than 1 or not, and then group by that, just to make it a little bit more explicit. But if you want to kind of skip that step of adding yet another column, then you can do it this way.
Yeah, John raises a really good point, is that if that information, something being greater than 1 is important, well, then store it. Don't compute it. So there's that sort of, I think of the computation as, well, okay, I've got to do this every once in a while. But if it's something that I constantly need, that's what a database is for, right? Go ahead and store that information and then just query the database. So there's that interesting sort of question always, do I compute it or do I store it? And there's a trade-off, right? Storage costs a little bit, computation costs a little bit. And so you have to decide sort of what's important.
But like if you had a database that had really detailed zip codes, these ones that have like multiple numbers, and then what you really want to do is group by zip code, well, then you might write a group by expression that finds only the first 5 letters of the zip code and group by that. And then you'd have group by the kind of regular zip code that you're used to. So this kind of stuff does happen. I think we did walk through this in the earlier
Yeah, I think we did
Q&A.
this
So
yesterday or Monday. Yeah, John?
yeah, but we'll do a fast version now, just like to remind everybody. You have to evaluate this, so that's 1. You have to evaluate that. But in order to evaluate that, you have to evaluate this symbol and this number. So now we're up to 2, 3, 4. Now I have to call cube on 3. That's not an instance of eval, that's an instance of apply. But part of the apply process is to now evaluate this expression. So we've done 4 so far. This expression is something that gets evaluated, so that's 5. We have to evaluate this, that's 6. We have to evaluate this, 7, 8, 9. So I counted 9 evals in this particular example.
And April, I think if you go back, I don't remember if it was Wednesday or Monday, we did a much more detailed version of that. You'll see it on the video on the course website.
Yeah, we did something like cube the cube of plus 1, 2, or something like that. We got
Yeah. Hey,
yeah.
John, before we answer this, your battery level is terrifyingly low.
It is, but
I know you
fortunately,
like to live in the moment, John, but that's ridiculous.
well, fortunately, the answer to this question is pretty short, which is that you don't have to think about recursive SQL either this semester or in most of your life. So it was a topic that we taught for a couple of semesters sort of experimentally, and therefore there's some old practice problems about it. But it's fairly unusual that you'll see a recursive select expression in SQL out there in the world. Like,
I don't think I've ever seen that.
If you dig around on GitHub long enough, you'll find some, but
Yeah.
you'd have to look pretty hard. So
Dig around in GitHub long enough, you'll find everything.
So right, this course used to teach another declarative programming language, a variant of Prolog, which has a fair amount of recursion in it, and we were kind of trying to capture that old flavor in SQL, and it's possible to do recursion, but it's just so restricted, and the syntax is so bizarre that it wasn't very enlightening, I think, to spend a whole week studying that. So yeah, I would just let recursive SQL go and ignore all those problems. And if you really want to read about it, you can find old versions of the class where we used to teach this. I'll show you how, just in case someone wants to follow up. If you go to insteeks berkeley.edu, you can find all the old versions of the course. So probably around 2016, we had some recursive SQL in there. Let's see. Yeah, there it is, recursive select. So if you want to watch a whole lecture on it, you could. But I don't think it's the best use of your time.
Yeah, I agree.
The next question was, can you have a select statement inside of a where clause? Let's go back to our very simple 1, 2, 3, 5 table. And the question is, can you have a select statement within the where clause? The answer is yes, but we don't cover it in this course, so you don't have to think about it again if you want to just kind of stick with the course material. But if you're just curious, it's a fine thing to wonder about. SQL allows for some sort of bizarre things to happen. So when you evaluate a select, you really should be thinking of that as producing a table. But if that table happens to have only one row and one column, then select is basically happy to treat it like an individual number. So you could write things like select star from numbers where the result of selecting the max n from numbers. Okay, so what would that give you? That would give you like a table with just one row and just one column that has the number 5 in it. You know, SQL is basically happy to let you treat this like the number 5. So then you could say something like, this is greater than n. And it will tell you that's 1, 2, 3. And basically just treat this whole thing as the number 5. Again, you don't need to know that for this course, but sometimes it's handy. So if, for example, you wanted like all the rows where the name, like you wanted the name of everybody whose height was the maximum height, you might write something like this. Yeah, good question. So how would you, if you had a table of numbers, how would you create a table of prime numbers? One intuition is that you need to know the primes in order to know the primes. Basically, you need to know the prime so far in order to check whether something larger is a prime. And that's one approach to finding out whether something's a prime number, but it's not the only one. A more brute force approach is, in order to figure out whether 12 is prime, you just divide it by every number, 1 through 11 before it. Not just the primes, but everything. The primes below it or in there somewhere. And you make sure that, you know, if 12 were prime, then only 1 would divide it evenly. So basically none of these other numbers would divide it. So I think probably the trick to finding a table of primes from a table of numbers is to first join the numbers with the numbers. So now you have pairs of numbers. Then you can group by the second number to ask yourself, is this thing prime or not? You figure out how many of the numbers it's been paired with divide evenly into it. And it better be only the number 1.